All right, welcome back to chapter 8.2. A couple more theorems for you dealing with parallelograms. First one, 8.5, for quadrilaterals parallelogram, then its consecutive angles are supplementary. Boy, I hope you remember that word from back in the beginning of the year. That always means, right, 180 degrees. You hear that word, it's 180. So let's look at what consecutive means. Consecutive means side by side. Maybe you recall when we did parallel lines and transversal. These two lines would be parallel. And the consecutive interior angles, that would be this one here and this one here as a pair, they would be supplementary. They'd also be 180. Likewise, this angle here and this angle here would also be consecutive interior, and they'd also be 180. Well, that theorem applies here. So consecutive again means side by side. So all around a parallelogram, if I could say it right, parallelogram, every consecutive pair is going to be supplementary. So here's a pair, x and y, they add to 180, x and y, add to 180, x and y. You catch on to my drift here? And they always add up to 180 as consecutive pairs. Okay. All right, and the other one, well, in fact, let me show it to you. We'll do the other one first then. Theorem 8.6 says if a quad is parallelogram, then its diagonals bisect. Oh, what's a diagonal? Let's have a look. A diagonal is a line drawn on any quadrilateral, and you'll see other quads that have diagonals. But this is a diagonal right here. I'm drawing a line for you now. And here's another one. Both of those lines I just drew are diagonals. And those are, at least on a parallelogram, they cut each other in half. So the one going this direction, single hash marks, each of those halves is equal. So if the full length of QS was 20, then this would be 10 and 10. The other one going across here, if that full length was 24, the two double hash marks, 12 and 12. So, and it kind of looks that way, so it's not too difficult to remember those. So let's try a little bit of math with these. Oh, before we do, let's try that. I want to show these to you. I like to show you this stuff. So here, again, look at the values of the pairs here. Let me get you some numbers that are nicer to work with, first of all. How about we go to 120? Yeah, 120. So if you look at any consecutive pair going around the parallelogram, 60, 120, that equals 180. Across the top, 120 AB, 120 to 60, 180. And B down to D, 60, 120. And all the way around, the consecutive pairs will be supplementary. And the other one real quick here is the diagonals are bisecting each other, cutting in half. You can see if I move this around, the values, we'll try to get some nice numbers here for you. It's too jumpy. I don't think I can get it for you. Nah, but you can see the numbers for each diagonal are cut in half. 13, 13, 18.6, 18.6. So let's do a little bit of math with these. And here's our first problem. It's a good one. It's parallelograms JKLM. And they want you to find all these lengths. And I've always said to you, don't go trying to find things, what they're asking you, because it's just easier if you're on your own, you go to the picture and label things up and find what you can. So for instance, I'm going to go for the easy stuff. I see KN. I'm going to zoom in really tight with this. KN is 2. This is 2 right here. Well, guess it's also going to be 2. Yeah, down here NM. So it's going to be 2 down here. That was pretty easy to do. Now look, 110 degrees right here. Where else do you find 110? Right, all the way up here at the L. So this right here is also 110 degrees. Now, using the new theorem we just got, where the consecutive angles add to 180. So, for instance, this angle and this angle that I now have to highlight, they should add to 180. Well, if you got 110 down at the bottom, what do you need at the top, or what the K is, to get to 180? Yeah, 70. So this angle is 70 degrees. Oops, degrees. And then, because opposites are equal on a parallelogram, this is also 70 degrees. And now you can answer the questions over here. Pretty short and easy, I hope. NM we found to be 2. KM is 4, because it's 2 and 2, right? And measure of JML, JML is 70 degrees. And KML, KML, yeah, it's a 35 degrees. It's cut in half. Okay, folks, have fun.